Hello, my name is Nicole Aguirre, and I'm here to record my Project One improvement. Um, so we're gonna start with explaining in detail how to create the piecewise function of a given model. So I'm just gonna set my phone up so you can see. Okay, so the first thing we want to identify are the segments. So right here we see that we have a linear line right here, so we will make a linear equation for it. And then right here we have a nonlinear and more specifically a parabola. So the first thing we would do for the linear to find the linear equation is recognize that since it's increasing, then the slope of the equation will be positive. And when we're trying to find a linear equation, we use the format y equals mx plus b. So to find the slope of the equation, which we know will be positive, we will have to use the slope is equal to y2 minus y1 over x2 minus x1. So the points that we're going to identify are 0 to 500 and 2 to 1,000. And we would use it to find the slope right here. So this would be 1,000 minus 500 over 2 minus 0. And this will ultimately equal to 50 for the slope. So we would input this right here into the linear equation. And then we would find what our b is. So we know the equation at the end of the line. Okay, to find this b, we can either look, because this 500 is on the y-axis, so we don't need to find this coordinate because we already know it. It's 500. But for purposes of the example, we want to show in detail how we would find it. And if this were in the case, then we would use point slope form. Which is y minus y1 equals m x minus x1. So we were to input the values. We could pick any point. So I'm just going to use this one. So it's going to be y minus 500. And then the slope, x minus the x coordinate. So this will ultimately be, and then plus 250 x, and then 2 times is 0. So we could put it in this form. Plus 500. So this would be the equation of this linear line right here. And for the domain, we want to look at where in what regions of the x-axis this linear line lies in. So as we see, it's from 0 to 2. And then we want to be more specific. So it's gonna be x is less than or greater than, and less than or equal to x. Oh no, x is greater than or equal to 0, but less than or equal to 2. So this would be our domain right here that we would input. So we're just gonna write this up here. If it's in the domain of, okay, so now we're gonna find the second region over here. And since it's a non-linear equation, more specifically a parabola, we would want to use the vertex form because it's giving us the vertex right here. And then, so that's what would help us find the equation of the line. So vertex form is y equals a H2 plus K. So we would pick the vertex, which is 4 at 500. We would input it into the equation, which would be A. So this is HK. And then to find the shrinking or stretching factor, which is A right here, we'd want to put in any other point that's on the nonlinear line to find what we are stretching by or shrinking by. So I'm just gonna use this point over here, which is 6 and 1000. So we just input it here for X and Y. So it's gonna be 1000 equals A, 6 minus 4 plus 500, which is, because this is the K that I never put in. And then, so we just basically solve for A. So this would be 6 minus 4 is 2, 2 squared is 4, so it's going to be 4A once you multiply it out, plus 500. And then when you move this and rearrange it, it's going to be 500 equals 4A. So you divide this out. So it's going to be A equals 125. So our line, once we put it back into our equation right here, it's going to be Y equals 125, which is our shrinking slash stretching factor. And it's going to be X minus 4 squared plus 500. And that's going to be the equation of the nonlinear line. And then for the domain, we want to see the region. So it's obviously from 2 right here to 6. And then we're just going to put it in the same format as before. X is greater than or equal to 2. And less than and equal to or equal to 6. So this is what we're going to want to use for our domain. So we're just going to put this up here to wrap it up. Okay, and this is how we would find our piecewise function. Okay, so now over here we're gonna explain how to find the limit of the given function using its graph. So write the limit of the given equation, and if there's a horizontal asymptote. So the first thing we will want to observe is that the horizontal asymptote is 700. So the equation for this would be y equals 700, because that's the asymptote of the equation. It's approaching 700 but never actually touches 700, and that's why it's the horizontal asymptote. Okay, it basically like flattens out there, and it'll just continue approaching 700 but never touch the line. So it'll just infinitely get closer. And then, so for the limit, we want to observe that the limit format is as the limit of x approaches. So x is approaching infinity. So as x approaches infinity, the function c of x, which says up here, c of x is approaching 700. As we see here, it never actually touches 700, but we can observe this from the graph because it's showing us what it's approaching, what the function is approaching. The line of the equation is clearly going right here. It's just gonna keep getting closer, never actually touch the line because due to the asymptote, to the horizontal asymptote. Okay. Yes, as it approaches infinity, it's gonna infinitely approach 700, which is why it's approaching infinity because it's infinitely going, but it wants to approach 700, but never actually will. So that's gonna wrap up my project 1 improvement. Thank you so much.